No question. No question. Okay. Now, no question, then I'm going to show you the second type of graph. The second type of graph is the velocity time graph. Oh, the way you interpret the velocity time graph is totally different from position time graph, right? The velocity time graph only show you the velocity. We do not know where is the position of the object that is moving. We don't know where is the position. We only know how fast it is moving, how far it has moved, and so on. Where is the starting point? We don't know. Where is the position? We don't know. Okay, so this is what the position time graph, the velocity time graph is going to show us. Right. Now again, we look at the same the same point, right? So there are 2 points during the first part of the journey, 0, 0, and 9, 7. The 0, 0, 9, 7, the meaning of 0, 0, 9, 7 here is different from the meaning in the position time graph. Here, 0, 0 means when the time is 0, that means you start your stopwatch. When the time is 0, the velocity is 0. That means when you start your stopwatch, the time, it is not moving. The object is not moving. So after you press the stopwatch, then only the object start to move. But where they start, from which position they start moving, we don't know. We just know that at first the velocity is 0, then now they start moving. Now when they start moving, of course the velocity is increasing, right? So when we look at the point here, 9, 7 means after 9 seconds it has achieved a velocity of 7 meter per second. Now, I mean, from here we also know there is acceleration already. There's acceleration. Then what we can read directly from the graph is the time and the velocity. Time and the velocity, right? That's all we can see. That's all we can see. Now, directly. Now, what we cannot see is the slope. The slope actually represents the acceleration. So I'm trying to find the slope of this line, the straight line, during the first part of the journey. So I use, again, if I have layout like this, so I use 7 minus 0 divided by 9 minus 0. So in our calculation for the slope, 7 minus 0 over 9 minus 0. And numerically, it is positive 7 over 9. What is the unit? Okay, we look at the unit along the y-axis. The unit is meter per second. Meter per second. The unit along the x-axis is second. So if we use meter per second at the top, divided by second again, so it will be meter per second square. You have to take note of the units. Actually, from the units, you can guess what is the physical quantity, whether it is acceleration or velocity. Okay, so we have calculated the slope to be positive 7 over 9 meter per second. And we say that the acceleration is positive 7 over 9. Acceleration is just a number. How to interpret this number? Positive means the velocity is increasing, and because it's a straight line, it is increasing at a fixed rate. What is that fixed rate? That fixed rate is every second they increase by 7 over 9. Every second increase by 7 over 9. Okay, so that is the how we are going to describe the motion of the object. We don't know anything about the position. Don't know the position. Right. So we look at the next part of the journey. The next part of the journey is from 9/7 to 10/0. Okay. Oh, never mind. We don't look at the next part of the journey. So we want to know during this period of time from 0 second to 9 second, how much distance they have covered, or how much is the change in position. How much is the change in position? So another hidden quantity is this displacement, or the change in position, delta x. Now this change in position is given by the area under the graph. Yeah, it is given by the area under the graph. So this is the area. So in order to find the change in displacement, I use a formula for triangle to find the area. And this area is in meter, right? Meter per second multiplied by second is meter, right? The unit is meter. So half, what is the base here? 9. What is the height? 7. So half 9 times 7. So it's 31.5 meter. So things that we can interpret directly is the position and the velocity. Things that are hidden, they are the acceleration and the change in displacement. Now, why I say change in displacement instead of displacement? Can you answer me? I have calculated this area here, and I say it is the change in displacement. I didn't say it's the displacement. No. Why, or why delta x? Why it is not the other? Delta means the change, change in displacement. Can you answer this? Why I say it's the change in displacement?
Uh, because wait
Do you know the position? Do you know the initial position and the final position? Position.
yes.
We don't know the position. We don't know the position. The initial position could be 0. The initial position could be 100 meters. We don't know where is the starting point. Actually, it means we don't know where is the starting point. Along the number line, I don't know where we are when I press the stopwatch. It could be along the number line, it could be 0. Along the number line, we could be at 10 meters when I press the stopwatch. We could be at 100 meters. The position could be at 100 meters when I start the stopwatch. I don't know what is the position, but I know between the final position and the starting position, the distance is 31 meters. This is the difference in the position, not the actual position. Not the actual position. Let's say if we start at 0, it will be 0 and 31.5. If we start at 100, when we start the stopwatch, our position is 100. So it is between 100 and 131.5. It is the difference in the displacement. This number here. This number here is the difference in the displacement. It is not the displacement itself. It is not the position itself. It is the difference in the position. Okay? Where is the starting point? Where is the ending point? I don't know. But I know the difference between the starting point and ending point is 31.5. Okay or not? You know what I mean by the difference in position now?
Yes, yes.
The difference in
Think
position is the
if I'm not too sure later, I can go back and see the video again.
no, you're not too sure. You ask me now. You ask me now. This number represents the difference in the position, right?
Yeah.
This is the
Mm-hmm.
difference in the position. We don't know the actual position, but we know the difference in position, right?
Position.
Okay, now we look at the second part of the journey. Let's say we look at the second part of the journey. Where is it? This one, is it? Yes. Now the second part of the journey is from 9-7 to 10-0. It means that during the 9th second, the velocity is 7. During the 10th second, the velocity is 0. Oh, 0, huh? Now the 0 here means the instantaneously at rest, because you know it's moving, 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 then stop, then they will start to come back. Surely they will come back, right? So this 0 here is not 0 forever. It is only 0 at that particular instant during the 10th second. Okay, now from,
I'll wait for teacher, wait for my mom call me. Sorry.
okay, okay.
Sorry. Can continue, sir. Sorry.
Okay, for the second part of the journey, I try to find the slope and the area. Those are the two things that we can find from the velocity time graph. So I find the slope. The slope is 0 minus 7, 10 minus 9. So 0 minus 7 over 10 minus 9. And numerically it is negative 7 over 9. The unit is meter per second square. Negative means the velocity is slowing down. They are experiencing deceleration. So this is consistent with what is shown in the graph here. What is shown in the graph here is that you see this is the velocity. It is dropping, 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 dropping until it becomes 0. Earlier on, it is increasing, increasing until the maximum velocity. Now it is dropping until it becomes 0. So this is consistent. Even though the object is slowing down, but still it is moving. So there will be distance covered. There will be a difference in the displacement. Okay. So the difference in the displacement again is given by the area under the graph. So the area under the graph is this one, right? Area under the graph is this for this part. And it is in the shape of a triangle. So if it's in the shape of triangle, I use the formula half base times height to find the distance covered, or the difference in displacement during this deceleration period. During this deceleration period. So I use the base is 1. Correct, 1. Then the height is 7. The height is 7. So it is half times 1 times 7 equals to 3.5 meters. Again, this 3.5 meters is the difference in position, or is the difference in the displacement, or the change in displacement. Do you still remember what is meant by the change in displacement or not? Can you tell me again what is the change in displacement?
Uh, the slope going down to the negative, is it?
That is the velocity. That is the velocity, right?
Okay.
Correct. If you are talking about velocity, then it's correct. The slope is going down, is negative, though the velocity is decreasing. That is correct. But during this period, when the velocity is decreasing, it doesn't mean that it is not moving. It is still moving, but slower and slower. Since it is still moving, there will still be distance covered. It will still cover a certain distance. Although it's moving slower and slower, there's still distance covered. That distance covered is given by this area under the graph. Given by this area under the graph. Of course, I tell you it is the distance covered. But if you want to interpret it as displacement, then it will be the difference in displacement, right? The distance covered is actually the difference in displacement. This is the starting point, this is the ending point. The ending point minus the starting point, it is actually the distance covered between the 2 points. Okay or not? It means like this lah. You look at this line here, right? This is the starting point, this is the ending point, right? So this is the displacement, the other end is also the displacement. The difference in the displacement, when I take this number or maybe this number minus this number, the difference in the displacement is actually the distance covered during that time. Okay or not? Right. Okay, right. So now we're going to look at the next part of the journey. Okay, next part of the journey. This is the negative part of the journey. This part here. How to show you this part? Huh? This part. Yes, this part of the journey, right? This dark blue line represents the graph. The light blue area represents the difference in displacement, or you can interpret it as the distance covered. Let me give you one example. My position now is 10 meters. Then after 1 second, my position is 15 meters. Okay. At first, I am 10 meter, my position 10. Later on, after 1 second, position is 15. What is the difference in position? What is the difference in the displacement? At first it's 10, then later it is 15. What is the difference in the displacement?
5.
5, correct. So the 5 is the difference between this point and this point. And you can also say the 5 is the distance traveled during this time. Okay or not? It is actually, you crawl along this line, so that 5 is actually the distance traveled. It's the same. The difference in displacement is actually the distance traveled. Let's say you don't turn back, assuming you don't turn back. Assuming that you proceed straight, you don't turn back. The difference in position is the distance covered during that time. Where they start, of course, now I tell you where I start, where I end lah. But in this question, where you start, where you end, you don't know. You only know the difference in displacement. Okay or not? So, so that is the meaning of difference in displacement. Now, for this last part of the journey, we have 2 points, 10, 0, and 13, negative 4. 10, 0, and 13, negative 4. So from here, I can find the slope. Negative 4 minus 0. 13 minus 10. Now, if I put it inside the slope, negative 4 minus 0 over 13 minus 10. Right. So answer is negative 4 over 3. The unit is meter per second. So this represents the acceleration. Then the question arises, this number, acceleration, is a negative number. What does that mean? Does it mean like earlier on here, acceleration negative number, and the acceleration here negative number, it carries the same meaning or not? Here negative number, here also acceleration, so negative number. Does it carry the same meaning? Don't know, right? Okay, then let me explain here. Negative 7 over 9. You see the number here, 9, then they drop to 9, they drop to 0. You see the height, the height. This is 9, at level 9, they drop to 0. So the velocity is actually dropping, the velocity is actually dropping. So that is the meaning of the negative here. But if you look at this part of the line, the velocity is 0. At first it's 0. Then it becomes negative 4. You see this negative 4 here, dot, 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 negative 4. 0 to negative 4. The object is accelerating or decelerating actually. At first the velocity is 0, then finally it's negative 4. Accelerating or decelerating actually?
Decelerating.
At first, 0. The
At
velocity
first,
0.
it's accelerating.
Then finally now it is negative 4. The velocity is negative 4.
So it went down.
Went down. So it is accelerating or decelerating?
Decelerating.
Actually, it is accelerating, but it is accelerating in the negative direction.
Direction, okay.
It's accelerating, but accelerating in the negative direction. So the negative here, in this case, in the second case, and the negative in the first case, although both of them carries a negative acceleration, but they mean different thing. One means slowing down, the other means accelerating in the opposite direction. That is the meaning of the negative in the second case, right? Very confusing now. Actually, what you need to do is like that. You need to imagine that it is moving along a straight line. You may know or you may not know the position, right? Right. If you know the position, then it's position time graph. If you don't know the position, then it's velocity time graph, right? Okay, then you actually need to work out the problem. You need to work out the problem, right? Never mind. So after I've shown you the examples, you can work out from the exercise at the end of the chapter. Okay, next part. Now, although it is moving in the opposite direction, it is still moving. As long as it's moving, there will be a difference in displacement. There will be a difference in displacement. So the difference in displacement is half base times height. Okay, half base times height. So what is the base? Base is this one. 3 seconds. 1, 2, 1, 2, and 3. 3 seconds. What is the height of the triangle? The height of the triangle is -4, right? -4. So end up you have displacement is -6. So the difference in position or the difference in displacement is -6, right? It means like this. From the first second to the 9th second, the difference in displacement is 31 meters, 31.5 meters. Although I don't know where is the starting point, where is the ending point, but I know the difference between these 2 points is is 31.5, sorry. Then during the second part of the journey, although it is slowing down from the 9th second to the 10th second, although it is slowing down, but it is still moving, so there will be a distance covered. That distance covered comes in the form of difference in position. The difference in position is 3.5 meters. It means that it will travel another further 3.5 meters. Okay or not? Right. Okay, then in the end, for this part of the journey, for the last part of the journey, the velocity is negative. The velocity is negative means they turn back. How far they turn back or not? You know how far they turn back? Turn back is
6.
-6. Okay or not? -6. They turn back 6 meter. Then finally, what is the final displacement? Okay, so finally it is here. So how far it is from the starting point? Okay, so we take 31.5 plus 3.5 minus 6, then you will know how far it is from the initial starting point. So it will be like this. So the final displacement, you look at this part here, the final displacement is after 13 seconds is 31.5 plus 3.5 minus 6. Why minus 6? Because they turn back 6 meter. So when they turn back 6 meter, the difference between your final position and the starting point is shorter already. You don't add the 6 meter to the end. You minus the 6 meter that is turning back. Okay, so minus 6 meter, so we know that this final displacement here is actually 29 meters. It's actually 29 meters. Any question? You just ask anything you want, anything that come across your mind.
No, I slowly getting it.